Hi everyone, welcome to the channel. Today I'll be talking about Noumena and well-formed concepts. I've done this presentation in the form of a mind map. This is a free tool called FreeMind. I'll put the link in the description below. I'll also upload this mind map so you can use it and it might help you follow along and help things stick. In the second video, I'm going to be going straight into mathematics, Euclid's requirements and the tweaks we want to make. So just bear with this presentation. It's very important because in this series I'm going to be totally deviating from the mainstream mathematics and the concepts such as infinity and what have you, which I consider to be not well-formed concepts. So a philosophical introduction is actually very important, so to provide a good rigorous foundation. So let's jump in. So in any rational study, in this case mathematics, everything is based on concepts. So what's the definition of a concept? A concept is awareness that's produced in the brain of a being which is capable of realizing or producing knowledge. The term was coined by Immanuel Kant, but these ideas are of Plato and the ancient Greeks of the time. So this philosophy revolves around wondering how something comes into existence, and then wondering if it did not exist prior, then it must have always existed. But then what is eternal? So, is matter eternal? Or what can be eternal? What else can be eternal? An example of something eternal is pi. Pi does not rely on anything for its existence. It's eternal, it has no parts, and it exists as perfect knowledge. Perfect knowledge is discovered, it's not invented. With perfect knowledge, instances are created. This is akin to the class object. This is akin to class object in programming, where an object is an instance of a class and there's a relationship there. So there are two kinds of concepts: creative or being specific, and realized or non-being specific. A creative or being specific concept is a concept that's produced in the brain through experience in the senses. And a realized or non-being specific concept is a concept that's learned from others. We want to know about well-formed concepts because one can have various concepts. One can think about infinity or unicorns, irrational numbers. One can conceive a concept can be absolutely anything, but we want to know what can be a well-formed concept. And what is a well-formed concept is a noumenon. I just want to make a quick note here that while a concept or definition may not be called right or wrong, it can be classified as well-formed or ill-formed. So calling it right or wrong or good or bad means well-formed or ill-formed, respectively. So, noumenon, or for plural, noumena. Noumena must be realized from rational thinking, and they must obey four essential requirements or guidelines. I have them here in order of importance, and I'll go through them in a bit. So, an example of noumena is all ancient Greek geometry. John Gabriel's New Calculus is a noumenon. It was discovered. It existed as perfect Platonic knowledge. It's based around well-formed concepts. So a noumenon is a posited object or event that exists without sense of perception. A perfect concept is a noumenon. It's a well-defined knowledge that cannot ever be changed or revised or corrected. And one must ask, where is the knowledge or invention when you haven't discovered or invented it? And yes, that's right, it exists eternally. So all Greek geometry is based around points, lines, circles, rational numbers. These all are noumena. They're well-defined concepts. So also thinking of lines, thinking of triangles, the Pythagorean theorem, or the fact that the sum of the angles of any triangle is always that of two right angles. This is also noumenon. This is also noumena. It exists a priori. And the evidence of such a thing are proofs. We can prove it, for instance, in the instance of a triangle, we can prove it for any right triangle, and we can do the same proof for any possible other right triangle that we can form, and it always exists. This thing always holds true. Whether we exist or not, whether we think about it or not, it's an a priori truth. Also in my case, using dynamic digital tools like GeoGebra and playing around with them, the fact that they auto-adjust just made that idea sink in even better, because however you pull the corners of a triangle around when it auto-adjusts, it just gives you some appreciation, the fact that you can try to change the triangle all you want. The theorem will and the sum of the angles, it will always apply no matter what, and it always did apply and it always will apply. We can't change that fact. It is a fact. It is perfect knowledge. So, to the essential guidelines of what makes something a well-defined concept. So we use steps 1 to 3 in order of importance, and step 4 is self-contained. So the essential requirements are 1. Reification, 2. Attributes, 3. Contradiction, and 4. Independence. So reification. For reification to apply, it must be possible to produce an instance of the concept, either tangibly or intangibly. Reification can be a descriptive name or noun. An example is straight line. Infinity cannot be reified. We cannot produce instances of infinity. A straight line starts from nothing. It's an intangible object. The prerequisites are point and line, or path. So a line is any distance between two distinct locations. A drawn line is not a line or straight line. So this means, I'll give you an example. That didn't work. So a drawn line is not actually a line, because this here is a line, this is a line, this can be a line, this red thing can be a line, because it's a path between 2 points. So those were merely visualizations or instantiations of the perfect concept that is a line. The objects represent distances. A distance is intangible, innumerable many, not infinite, between two locations and points, two locations / points. So from these innumerable many, though, only one such distance is unique, and that is the shortest path or line, which we call the straight line. So attributes. An object realized or reified from an idea should always be defined in terms of the attributes it possesses, never in those which it lacks. An example: straight line. The main attribute of a straight line is the shortest distance or path between any 2 points. So if we define something in the attributes which it lacks, for instance, irrational number, you may as well be thinking or talking about innumerably many other concepts. So in the mainstream definition, a number that cannot be written in the usual way as a fraction p over q, where pq are rational numbers. This is not a well-formed concept because it actually tells us nothing about the idea. It tells us what a number isn't. Another example, square root 2. Square root 2 is an incommensurable magnitude or distance that's realized from an attempt of measuring a special distance in geometry that is a failed attempt at measuring a diagonal of a square using one of its sides. If these are not numbers, then a gorilla and a banana are also rational numbers, because neither can be expressed as a ratio of numbers. Contradiction. Point 3. Consideration of contradictions that may arise. So an example: definition of a line as all the points that describe distances as one would traverse the same. This is the Euclidean and mainstream definition. This definition fails step 2, which is attributes, because it requires the notion of infinity. This is it fails step 2 because it is defined in attributes which it lacks, and it also fails fails step 1 because it has the notion of infinity, that of infinite points, and this is a not well defined concept. Even the word infinity is self-contradictory in a way, because the word infinity means for something not to be finite. So it doesn't have any attribute because the word itself is coined in. It can't be a well-defined concept because it's coined as a negation of something. The points cannot be enumerated, they're innumerably many. A line does not consist of points any more than a road consists of distance markers alongside it. Points are dimensionless, as we well know. So once a concept has been reified and defined, there are limitations on being well defined, and this is why one needs to have checks for contradictions until the concept becomes axiomatic over a long period of vetting. In terms of attributes it possesses, it has to be vetted. This is done by always verifying that any results stemming from its use do not produce logical contradictions. Now 4. Independence. Last requirement. Can a concept be realized by any other intelligent being independent of any input from us? It must exist outside the human mind and any other mind. Any alien should arrive at the same concept if they were to discover it. An example is pi. Pi is a constant. It applies for all possible circles. It's the ratio of magnitude of the circumference compared to its diameter. And we must ask ourselves, in this case, can anyone or anything arrive at a different idea in any other way, as it pertains to the circle? The only way, the irreducibly way, to consider a circle's diameter is to compare its circumference is to compare it to its diameter, and the relation always holds for any circle, as I mentioned previously with the triangles. That's why these ideas are perfect knowledge, they're Noumena. So yes, step 4 is independence, and as I said, it's self-contained. So it's used to help determine if newly realized concepts which use no Noumena can graduate to Noumena or be classified as Noumena themselves, hence no circularity in terms of definition. So that's it. I hope you have some understanding of what Noumena and well-defined concepts are, and this is very important to begin our journey with proper foundations for mathematics. Thanks a lot. Take care.